In this video, we look at a couple different properties of sums that can help us in making our calculations much more simple when evaluating sums. As you can imagine, writing out all the terms of a sum can quickly become tedious work. The following sum properties can be helpful in making your calculations easier. Here's our first sum property. We have the sum from I equals 1 to n of c is equal to c times n, where c is a constant. In other words, we are taking the sum of a constant, meaning that every single term in that series is going to be that same constant c. For example, here we have the sum from I equals 1 to 50 of 3. 3 is a constant, and we certainly could list out every single term in this series, and every single term in the series would be 3. To evaluate this sum, we could write out 3 plus 3 plus 3 plus 3 plus 3 50 times, and go ahead and plug that in. Or we can simplify this expression by using this property. The sum from I equals 1 to n of c is equal to c times n. We take the constant and we multiply it by n, the number of terms that we are adding together. In this case, we end up with 3 times 50, which is equal to 150. So, as you can tell, much easier to evaluate our sum using this property rather than writing out all of the terms of the series. And using this property is probably even faster than plugging this into your calculator. Let's take a look at a couple more. Here, we have the sum from I equals 1 to n of c times a subscript I is equal to c times the sum from I equals 1 to n of a subscript I, where c is a constant. This property tells us that if we have a constant multiple inside of summation, that's a number connected by multiplication, we can factor out that constant multiple from our series. For example, we have the sum from I equals 1 to 4 of 2/3 times I plus 1. Now, we don't necessarily have to use this property. We could solve this just by writing out all of the terms. Notice to get the first term, I would plug in 1. To get the second term, I would plug in 2. To get the third term, I would plug in 3. And to get the fourth term, I would plug in 4. That would give me 2/3 times 2 plus 2/3 times 3 plus 2/3 times 4 plus 2/3 times 5. And we could absolutely calculate out the sum in this manner. However, it is often convenient to factor out our constant multiple. 2/3 is a constant connected by multiplication. We can factor it outside of the sum. And now I can just take 2/3 and multiply by the sum from I equals 1 to 4 of I plus 1. So the first term would be 2, the second term would be 3, the third term would be 4, and the fourth term would be 5. And now I can add all those values together and then multiply by 2/3, making my life easier that I don't have to multiply everything by 2/3. Okay, much easier to add these numbers together and multiply by 2/3 in the end. 2 plus 3 gives me 5, plus 4 is 9, plus 5 gives me 14. 14 times 2/3, well, that gives me 28 over 3 as our final solution. Again, both of these are completely acceptable. However, factoring out constant multiples can make our calculations easier. And down the road, as we continue to study summations, you will definitely find that factoring out constant multiples is going to help you in certain instances. One more property of sums to look at here. The sum from I equals 1 to n of a subscript I plus or minus b subscript I is equal to the sum from I equals 1 to n of a sub I plus or minus the sum from I equals 1 to n of b subscript I. This property says that if we have multiple terms inside of a summation connected by addition or subtraction, I can essentially distribute the summation to each of the terms and rewrite it as the sum or difference of two separate summations. The sum from I equals 1 to n of a subscript I plus or minus the sum from I equals 1 to n of b subscript I. I can take the sum of the individual parts on their own and combine them afterwards. For example, the sum from I equals 1 to 3 of I squared minus 2I. Now, in this particular sum, we're only adding up 3 terms, and we could very easily plug in 1 to get the first term, 2 to get the second term, and 3 to get the third term, and add them all together. We would end up with 1 squared minus 2 times 1 plus 2 squared minus 2 times 2 plus 3 squared minus 2 times 3. Now, a lot of parentheses have to go in there, but we could make our life easier by separating this sum. We could rewrite our sum from I equals 1 to 3 of I squared minus 2I as the sum from I equals 1 to 3 of I squared, notice that's our first term, minus 2 times the sum from I equals 1 to 3 of I. And notice that 2 is a constant multiple in front of the I, so we actually factored out that constant multiple and split it up into 2 separate summations. Now we could evaluate each of these sums individually, starting by plugging in 1 and adding values until we plug in 3, leaving me with 1 squared plus 2 squared plus 3 squared. That would be our sum. Our first sum here comes from that, minus 2 times, this would be our second sum, coming from these terms here, okay? 2 times 1 plus 2 plus 3. Well, 1 squared is 1, plus 4 is 5, plus 9 would be 14, minus 2 times 1 plus 2 is 3, plus 3 is 6. That gives me 14 minus 2 times 6, or 14 minus 12, which is equal to 2. All right, and so there we have our sum and difference property for summations. Again, how does this help us out? Well, now we just have fewer parentheses to work with. Is it absolutely necessary to use the sum formula in this case? No, but it can make your calculations easier. And it definitely will be helpful as we continue to study sums down the road. So make sure you understand all these properties of sums.